This is it, the moment we've all been waiting for, Module 7, Part 5, where we are solving equations with radicals. I have actually been looking forward to this because this is the good stuff, like when we're actually solving equations. We were learning all those skills about working with radicals to build up to this point, and now we're here, and we're so happy to be here. So complete your guided notes for Module 7, Part 5 as you go along. So if I want to solve a square root, we are going to square both sides of the equation to eliminate the square root. And then we need to check our proposed solutions in our equation and discard any values that are not solutions. So, for example, if I have the square root of x is 5 and I square both sides, I get x equals 25. Well, if I plug that back in, the square root of 25 is 5, check, right? So this would be our solution. Our solution in this case is when x is 25. And I'm sure you could have told me by looking at this, like, okay, Dr. Miller, if you plugged in 25, we would get 5 out. That's why that's going to be our x value. But these equations get a little more complicated than just a singular square root of x. Let's take a look at some of those. So if I have the square root of 3x plus 4 equals 8, I can't exactly right now envision what I could substitute in for x in order to make this a true statement. Maybe it's a fraction, maybe it's a negative. Let's find out. So what I have to do is make sure my radical is all by itself, which it is, good job. Then I have to square both sides of the equation. Squares undo square roots, so I'm left with 3x plus 4. They just cancel out like that. Equals 8 squared, which is 64. And now I can subtract 4 from both sides. I have 3x equals 60. I divide both sides by 3, and x equals 20. Let's plug that back in and make sure we have a true statement. If I have the square root of 3 times 20 plus 4 is 8. That's the square root of 60 plus 4 is 8. The square root of 64 is 8. 8 is 8. That's a true statement, right? We need to make sure when we're substituting in, we're getting a true statement. Because if for some reason I solved this and I got that the square root of negative 64 was 8, that's false. We can't take the square root of a negative. So that's one thing we need to be wary of. Next example, isolate the radical. My radical is not isolated, so I'm going to subtract 3 from both sides. I have the square root of 5x minus 1 is a negative 3. I then need to square both sides. So I have 5x minus 1 is 9. I add 1 to both sides. 5x is 10. Remember, we combine like terms. We're trying to solve for x. I divide both sides by 5 and get x is 2. So let's check that in our original equation. I have the square root of 5 times 2 minus 1 plus 3 is 0. That's the square root of 10 minus 1, 9 plus 3 is 0. I get 3 plus 3 equals 0. This is false. This is false. And we might have actually been able to see it was false earlier when we had the square root of x minus, the square root of 5x minus 1 is negative 3. Square roots can never be negative. And that would be an example for us to see that this had no solutions. When you get a false statement, no solutions. This isn't a solution. We discard any values that aren't solutions. I only found one solution. When I plugged it in, I got a false statement. That's why there's no solutions. We'll do some more of these. So I have negative 3 square root of x minus 2 equals 25. So I can add 2 to both sides. So I have negative 3 square root of x is 27. I can divide both sides by negative 3. So I have square root of x is -9. And that might already be our hint. Okay, square roots can never be negative, but let's follow our steps. We square both sides. I get x equals 81. So I can then go ahead and plug this in and check. I have -3 times the square root of 81 minus 2 is 25. I get -3 times 9 minus 2 is 25. That's -27 minus 2 is 25. -29 doesn't equal 25. So this is false. Because it's false, there are no solutions. We disregard when x is 81. Five the square root of 6x plus 4 equals 2. I need to isolate my radical, so I subtract 4 from both sides. I have the square root of 6x is 2. I can square both sides. I have 6x is 4. I divide both sides by 6, so x is 4/6. We simplify that to be 2/3, and then we substitute it back in. 5 the square root of 6 times 2/3 plus 4 is 6. That's the square root of 12/3 plus 4 is 6. 12 divided by 3 is 4. The square root of 4 plus 4 is, I don't know why I wrote 16. I said 6. 2 plus 4 is 6. 6 is 6. This is true. X equals 2/3 is my solution. Next, we need to isolate the radical. This time I've got two radicals, and they are both isolated, so I can square both sides. The square root of x minus 1 is, after I square it, the square root symbol goes away. This is what happens when we record too many YouTube videos back to back. So I have x minus 1 is 3x minus 11. Now I can combine like terms. So I have -2x equals -10. So x equals +5, and we plug that back in. So I have the square root of 5 minus 1 equals the square root of 3 times 5 minus 11. So the square root of 4 equals the square root of 15 minus 11. The square root of 4 is the square root of 4. 2 equals 2. Perfect. This is our solution. Next, I have the square root of 4 minus x equals x plus 2, and I need to square both sides. My radical's isolated. We square both sides. When I square this left-hand side, I get 4 minus x. But when I have x plus 2 squared, that means I need x plus 2 times x plus 2. We're going to have to FOIL. Now I can combine like terms. I can add x to both sides. I can subtract 4 from both sides. So I have 0 is x squared plus 5x. Well, in order to solve this for x, I need to factor. This isn't a true trinomial because there's no c term as my constants canceled out. So I have 0 is x times x plus 5. I set both of these equal to 0. So I have x is -5 and x is 0. I now need to check both of these into my equation. The square root of 4 minus 0 is 0 plus 2. The square root of 4 is 2. That works. So x is 0 is one of my solutions. I have the square root of 4 minus a -5 is -5 plus 2. So I have -3 on the right-hand side. We can already see a problem because the square root can't be negative. I have the square root of +9 is -3. This is false because 3 doesn't equal -3. And so this is not going to be one of my solutions. So my only solution in this case is when x equals 0. Last, but certainly not least. Yes, this is indeed last. I'm going to take the square of both sides because my radical's already isolated. I have x squared minus 4x plus 9 equals x minus 1 squared. So I have x minus 1 times x minus 1. So I have x squared minus 4x plus 9 is x squared minus x plus 1. All right, now I need to start combining like terms. I can subtract x squared from both sides, and I see, oh, my x squared terms go away. That's pretty nice. I can now go ahead and solve for x in my usual way. I could add 4x to both sides. So I have 9 is 2x plus 1. I subtract 1 from both sides. I get 8 is 2x. That means x is 4. And I still have to check my answer. So I've got 4 minus 1 on the right-hand side here. I've got 4 squared minus 4 times 4 plus 9. Well, 4 squared and 4 times 4 are the same thing, and we're subtracting them. So I have the square root of 9 is 3. 3 is 3. Perfect. X equals 4 is our solution.